first topic that we discuss when we're talking about calculus is limits. And it's easy to kind of evaluate functions. Like here we have f of x is equal to x squared plus 2x plus 3. We know that it's easy to evaluate that f of 2, if we put this in, we get 2 squared is 4, plus 2 times 2 is 4, 4 plus 4 is 8, plus 3 is 11. And if we actually calculate the limit, we would also find this is 11. But if we look here at g of x is equal to x squared minus 9 over x minus 3, well, if we substitute in 3, we're going to get a value that doesn't exist, right? This does not exist. It's undefined because we would have 9 minus 9 over 3 minus 3, which is equal to 0 over 0, which of course is undefined. But we actually do have a limit of this, and that limit is equal to 6. Why? We're going to learn that right now. Well, we have 3 ways that we can evaluate limits. Visually with a graph, numerically with a calculator, and algebraically using algebra, using math. So first we're going to evaluate these graphically. If you look here, this first graph, we could calculate, well, what is f of 2? Well, if we go to 2, we actually have a hole there, so we don't have anything. F of 2 is none. There is no value at f of 2. But if we look at the limit as x approaches 2, well, if we come from the right and we look down, where is it approaching? And if we come from the left, where is it approaching? Because these are coming to the exact same place, they are both approaching 4. The limit as x approaches 2 is equal to 4. Let's look over here. F of negative 4, that's an asymptote, so that's also none. There is no value there. And if we look at the limit as x goes to negative 4, well, if we're coming from the left, this goes up to positive infinity. If we come from the right, this goes down to negative infinity. And because those are going in opposite directions, they're not coming together at the same point, this is undefined, so this does not exist. There is no limit as x approaches negative 4. Let's look down here. F of 5, well, if we go to 5, we actually do have a value there. F of 5 is equal to 3. That's nice. But if we look at the limit as x approaches 5, well, if we approach 5 from the left, we do get to 3. But if we approach 5 from the right, we get, well, it looks like we're at 6. And because those are different and because they're not meeting at the exact same place, here our limit does not exist. If we look here at this parabola, f of 2, we go here to 2, it's at negative 4. We look at the limit as x approaches 2. If we come from the left, it goes down to negative 4. If we come from the right, it goes down to negative 4. So our limit and our function values are actually the exact same here. Let's look at a few more. Here we're looking at f of 3. Well, f of 3 does not exist because we have an asymptote there, so does not exist, D and E. And the limit as x approaches 3, if we come from the left, we're going to negative infinity. If we're coming from the right, we're going to negative infinity. So our limit here is negative infinity. You could also say here that the limit does not exist because some people would argue that you can never actually reach negative infinity. And that's fine. We don't really have to dive deeper into that. That's just knowing that information. Here, f of 2. F of 2 is equal to 1. We actually have a value there. But the limit as x approaches 2. Well, as we approach 2 from the left, it looks like we're approaching 4. As we approach from the right, we're approaching 4. So here is a really good example of how the limit and the value of the function can be different. Let's look at these last two here. The f of 1, well, there's no value at 1, so f of 1 does not exist, or none. And limit as x approaches 1. Well, we're coming from the left, we're coming from the right, we're going to 2 different places. Again, the limit does not exist. I should put none here. And here, f of 2, there's a hole, so we have no value here at f of 2, none. And the limit as x approaches 2, if we come from the left, we're going to 4. If we come from the right, we're going to 4. So the limit is, of course, 4.